SL2, this optional topic is composite functions, and we talked about this way back in the beginning of the year this year, but just in case, wanted to give a video in case you haven't thought about it since. And remember, composite functions are when you put two functions or two or more functions together, and they are often written as this. So, and you say f of g of x. And what this means is it translates as you're going to take the function g of x and put it into f of x. So the function that's written second gets put inside the first function. So if we look at an example where f of x is x squared plus 1 and g of x is x over 4, we can find f of g and g of 4, and we can do that pretty simply. Let's first find f of g, and we're going to put g of x inside of f of x. So x of 4 is going to go inside of the f function. So x of 4 takes the place of every x inside of f of x. So we only have 1, but it is squared. So we're going to have x of divided by 4 squared plus 1. And that's pretty simplified. You could simplify a little further as x squared over 16. I said squared, but root 6, not sure. X squared over 16, and then plus 1. So either would be fine, this step or here, to find part A, f of g. For B, g of f of x, we're putting f of x inside of g, so f of x is that x squared plus 1, and it's going to take the place of all the x's in g. So in this case, again, we have 1x, so it's x squared plus 1 divided by 4. That's g of f of x. Now remember, when you have numbers, let's say they want us to find f of g of 4, you can do it all in one step or in two steps, and you're going to put 4 inside of g and then that number inside of f. So I'm going to go ahead and break it into two steps and do g of 4 first. Remember, g of x is x over 4. So g of 4 would be 4 over 4, which is 1. And now f of 1, that function is x squared plus 1. So 1 plus 1 is 2. Now, since we had already found, so the f of g of 4 is 2, but since we've already found our composite of f of g of x, we could check our work by plugging in 4 into our what we found for f of g of x. And 4 squared over 16 plus 1, we have 16 over 16 is 1, and 1 plus 1 is 2. So either way, you're going to get 2 for f of g of 4. So two ways to find that. But whenever you're given a number to put inside, you end up with a number, and then if they want you to put an expression inside, you'll end up with an expression. Let's look at one IB problem next. And in this example, part A is asking for the composite. Part B is asking you to find the inverse. Remember, g to the negative 1 of x is the inverse. So this is going to be explained, reviewed in a different video. So if you forgot how to find the inverse, please watch that video And part C is then, once you found the inverse, then they want you to find the composite of f of the inverse of 5. So in this video, I'm only going to talk about part A, but I wanted you to see that sometimes these are put together in one part in a 5-point question on the IB exam. So let's just try part A, and they want g of f of x. So our f of x function is going inside our g function. Our f of x is 7 minus 2x. That's going to take the place of the x in the g. So 7 minus 2x plus 3, which would equal 10 minus 2x. So that is the answer for part A. Okay, so why don't you go ahead and try problem 1 and problem 2, and then bring it back to see if you completed it correctly. Okay, for the first one, that was pretty straightforward. You just had to find f of g of x and put g of x inside of f, and it would, the final answer would be 6x minus 15. For part 2, they pulled in some trig functions. So first you had to find f of pi over 2. So that we just substitute in pi over 2 for x, and that would result in cosine of pi, which we know is -1. Now part B is g of f of pi over 2. So we already found f of pi over 2, so we know that's -1. So now we have to find g of -1. So we plug in -1 for all the x's and g. There's just one x, so it's -1 squared times 2 minus 1, which is 1. For part C, they want us to, they're giving us g of f of x, and they're saying that can be written as cosine kx. They want you to find the value of k, and that k is a integer. Okay. So first we want to find g of f of x, and that could be found by plugging in f of x inside of g. So that is 2 times cosine squared of 2x minus 1. Now we have to think about how we're going to get this cosine squared to be written as cosine kx. And it should be triggering that a trig identity is what we need to look at. So it's going to be a double angle one, and there's 3 parts to our cosine double angle formula, and the only one that we have information for is cosine squared. So let's take a look at that here. We don't have sine, so we can't use this one, and this one, so we're going to be using this one that's equal to cosine 2 angle. And interesting enough, it's almost the same exact formula here. So if we allow theta to be equal to 2x, it will be the same formula. So 2 cosine squared of theta minus 1 is equal to cosine 2 theta. Now if we plug in 2x back in for theta, we can find that cosine of 2 theta equals cosine of 2 times 2x, which equals to cosine 4x. So now we have our g of f of x written the same way as they're asked, and we can see that k equals 4. Okay, if you want to try some more problems, they can be found in your book on page 27, exercise 1D. And remember, the answers in the back of the book. All right, thanks for listening. Have a good night.